Hey guys, today we're going to continue a little bit with our transversals. We'll do a few problems with making equations with them, and then you'll have time to practice. So when working with the transversals, the main thing is just knowing the angle relationships, because that's going to give you the equation that you can make to solve for variables. So first one we're going to look at, this is the first slide on here. We are given these two lines, line C and line B, and we have transversal A coming through, something like this, and we're given that C is parallel to B. We know this angle is 8x, we know this angle is represented by 4y, and this angle is represented by 64 degrees. So we have one angle measurement, and we're going to try to find x and y. And again, it's all about knowing relationships between angles. So if we try to find x first, the relationship between these two angles is that they're vertical angles. So 8x is going to be equal to 64. Divide by 8, divide by 8. So x is equal to 64 divided by 8 is 8. So your value for x here is 8, because this angle should equal 64. 8 times 8 would be 64. Now if you're trying to find y, looking at these two angles, well, they are corresponding angles. The lines are parallel, so therefore they're going to be congruent. They're going to have the same measure. So your 4y is going to be equal to 64. Divide by 4, divide by 4. So y is equal to 16 here, because this angle needs to equal 64, and 16 times 4 is 64. So there's our first one. Moving on to our second one. Our second one, we are given these two lines. We have line, looks like N, line P, and then we have a transversal M, and we are told that N is parallel to P. Now we know this angle has a measure of 56 degrees, this angle is just y, and this angle has a measure of 3x plus 2. So let's say we try to find x first. Looking at these two angles, we should notice they are vertical angles, so we can make the equation 3x plus 2 equals 56. And now you're just solving for x. So subtract 2, 3x equals 54. And if you divide by 3, you'll get x is equal to 18. Now to find angle y doesn't have any specific relationship that we know of with the 56 or with the 3x plus 2. But if we think about the 56, since these two lines are parallel, we know that the 56 corresponds with this angle up here, making this angle 56 degrees. And then the relationship between these two, well, they're going to have to be equal to 180 because they're supplementary. So y plus 56, these two angles added together should equal 180. They make that whole straight angle between the two of them. And then you're just solving for your y. So when you subtract, you should get 124. That's your value for y in this one. All right, on to our last one, and then I'll give you a chance to do some on your own. So our next one, we have these two lines, line A and line B. This one looks a little bit different. Line A, line B. We are told that A is parallel to B. It's good to know. We have a little transversal C right here, and we have this ray D that comes out, and we are told that C is perpendicular with D, and we're going to get back to that in a second. So 7y plus 6 is this angle. This angle has a measure of 35 degrees, and this angle has a measure of 5x. So these two lines are parallel. If you ignore the ray D, you'll see different angles that we have here. but we need to account for the D right now. That's going to help us with these two. The fact that C and D are perpendicular means that where they intersect, so this point of intersection between D and C, you're going to form right angles. Now D doesn't continue all the way through, so we're really only going to have two right angles here. One is right there, and the other is this angle over here. So by looking further, the 35 degrees and the 5x, they should have a sum of 90 degrees. These two angles are complementary because they should add up to that whole 90 degrees between the two of them. So we can make the equation 35 plus 5x should equal 90. Subtract your 35, subtract your 35. 5x should equal, well, when you subtract, you get 55. Divide by 5. So x should equal 11. But now we need to find the 7y plus 6. And now here's where you want to ignore that D. So you have line A and B are parallel. Line C is your transversal. If you look at the 5x, or the 55 degrees, 5 times 11, that corresponds with this angle down here. These two angles are corresponding angles, so they're equal to each other. 7y plus 6 needs to equal that 55. And then you just subtract 6 from both sides, you get 49, divide by your 7, so y should equal 7. And then you're all done. Like I said, with transversals, it's all about knowing angle relationships. If they're equal to each other, are they supplementary? If there's an extra little ray or line in, are they complementary? That's the main thing in setting up the equations. So if you want to try some more on your own, the fourth slide here, there's 5 different problems. You can try them on your own, and then I'm just going to go through all of them here, so you'll have video explanation for each one. If you're feeling good and you want to go into the worksheet, then you can stop watching now. But I'm going to go through the 5 of these. I'll start with the blue in the top left. Our blue one, this is what we have. We have 2 lines, and we're not given letters for these lines, but we are given the symbols that look like this. That just means the lines are parallel to one another. We know this is 60 degrees, and this is 8x minus 4. So our relationship between these two angles is that they are alternate interior angles, and they should be equal to one another. So 60 should equal 8x minus 4. When you add 4 to both sides, 64 equals 8x. Then when you divide by 8, you're going to get x is equal to 8. So for your first one, you should have x is equal to 8. And I'll leave that one up there for now. I'll erase it when I finish this next one. Our next one, we have these 2 lines, and a transversal going through them. We have this angle is 2x plus 1, and this angle up here is 83. Now if we look at the angles that were given, there's no relationship between these 2 angles. But we can use certain relationships that we do know, because these lines are parallel. So if this angle is 83 here, well then we know this angle is 83. We also know through corresponding angles this is 83, and we know that through alternate exterior this is 83. And we can use these angles with this 2x plus 1 now. Between the 2 angles, if we use these two, when you add them together, they should equal 180. They're supplementary. So 2x plus 1 plus the 83 should equal 180. Go ahead and combine your like terms. 2x plus 84 should equal 180. Then you subtract your 84 from both sides. So 2x should be equal to 96. Divide by 2, and therefore x is 48 for your second one. So the first one, they were equal to each other. In our second one here, they ended up being supplementary. We had to use some of the other angle relationships that we knew. Alright, let's move on to our next 2. We'll do the yellow one now. So our yellow one here, we have line B, line A, and transversal K. Here's K coming through. And we are told that A is parallel with B. We are told this is 12x, and this is 26x plus 28. Alright, and the relationship between these two angles. So A and B, these are parallel lines. We have a transversal, so certain angles are going to be congruent. Now if we look, we don't have any angle measurements, but I'm going to look at the 12x here. The 12x, if we use its corresponding angle, this angle right here corresponds with this. We don't know the measure of this angle, but we know we can represent it with 12x because it's congruent to this angle, which is 12x. And then we can use that to solve for our value of x. We can use that because these two angles are supplementary. So 12x plus 26x plus 28 is equal to 180. Combine your x's, we should have 38x plus 28 is equal to 180. You want to subtract your 28 from both sides. So we have 38x is equal to, when you subtract your 28, you should have 152. And then when you divide by your 38, divide by 38, you should have x is equal to 4. So for this one, you end up with a value of x equal to 4. And again, we had to use some of those special relationships that we know to figure out an equation that we can create. Alright, so let's move on to our purple one, the bottom left. And we have K and A again. So here is A, and we also have B again. A, B, and transversal K. So we know A is parallel to B. We know this is 5x. And we know this is 3x plus 42. And if we look at the two angles that were given, well, we'll see that they are corresponding to one another. And since these two lines are parallel, they're cut by a transversal, corresponding angles are congruent, which means they have the same measure. So we can make the equation that 5x is equal to 3x plus 42. Get your x's all to the same side. You have 2x is equal to 42. Divide by your 2. And then your x is equal to 21. So your value of x that'll make this work is 21. And actually, if you even substitute back in 5 times 21, where you're going to end up getting 105. So this angle is 105 degrees. 3 times 21 is 63, plus the 42. Well, that equals 105, as it should, because these two angles should be congruent. So this one you can check and see if you have the right value here. And our last one is this little green one in the bottom right. So the green one we have, let's see, draw it nice and big. We have line A, we have line B, we have line D, and we have line C going right here. And these three lines all intersect at the same point. We are told this angle is 117, this angle is X, this little angle is Z, and this angle is Y. Okay, so we are told that B is parallel to D, and A is perpendicular with line C. So right off the bat, we should see angle X is vertical with this 117, so X should equal 117. Easy one. If you look at the fact that A is perpendicular with C, so just focusing on A and C, those are these two lines here, going across horizontally, going vertically. Since they're perpendicular, they're going to make right angles. So this is a right angle, this is a right angle, and here are right angles. We have 4 right angles. So right away, we're kind of given y. Y is 90 degrees. Now to find z, we have to do a little bit of work. We're going to need to use the transversals here. And it can be a little tricky. So we know this is 117. If you ignore line C, like try to not picture line C, imagine it's not there. And we're going to focus on this angle here. X is going to be the same as angle Y plus this little extra. See how this angle here, this corresponds with like this whole angle, the Y plus the little extra. And we know Y is 90. So 117 is equal to Y, which is the 90, plus the little extra. Let's call the little extra M. So the 90 plus M. If you subtract 90 from both sides, you're going to end up with the little m is 27. So this little angle here is 27. And now we can use what we know about complementary angles, because A and C form that 90-degree angle, and this 90-degree angle is made up of Z plus the angle M that we called here. So Z plus M should equal 90. Well, M is 27. So Z plus 27 should equal 90. Subtract your 27. And then Z is going to be 63. And that's your value of Z. So for this one, you had to use your corresponding angles to figure this out. You also could use, if you wanted to, alternate interior angles. The 117 would tell you this whole angle is 117. And then you have supplementary angles, so then 117 plus Z should equal 180, and you'll end up with 63 that way too. There's usually more than one correct path. That's what's nice about transversals. And if you know the angle relationships, you can use what you're comfortable with. The more you know, though, the easier problems become. Alright guys, so go practice some on your own. Hope you have a great day.